Welcome everybody to part 2 of 6.1. In this part, we're going to be talking about the angles of a polygon. So starting off with this polygon angle sum theorem. So it states that the sum of the interior angles measures of a convex polygon with n sides is equal to n minus 2 times 180. So you take n, which is the number of sides, you subtract 2, and then you multiply that by 180, and that is what the sum of the interior angles is equal to. So if you add up all the interior angles, it equals this value. Why? Okay, why? Well, hopefully we already recognize that from previous sections, previous chapters, we learned that the angles, the interior angles, so these three angles here in a triangle add up to 180, right? You can see here we have a progressively increasing number of sides. So we have a quadrilateral, 4 sides, a pentagon, 5 sides, a hexagon, 6 sides. And what you can notice is as we sort of strategically separate these shapes into more triangles by kind of drawing in some diagonals. So here we have this diagonal line drawn in. We create 2 triangles. What's more, all of the angles of the triangle, so this triangle right here, and this other triangle right here, all of these angles match up with the angles of the polygon, right? The angles of the quadrilateral are just the same angles that are involved in these 2 triangles. Well, that means that's 180 and 180. So 2 times 180 is 360. The angles of a quadrilateral are going to add up to 360. Kind of cool, right? Same idea here. So from this vertex, we can draw a couple diagonal lines in here in this pentagon, and we create 3 triangles. So this triangle here, this other one right here, and finally this third one right here. And again, what you can notice is that all of the angles of the pentagon, this one, this one, this one, this one, and then finally this one, match up with simply the angles of the triangles. So we have 180, 180, 180, 3 times 180, which is 540 degrees. So the angles of a pentagon will always add up to be 540 degrees. And then extrapolating that even further, hexagon, we can see it's triangle, 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 triangle. There's 4 total triangles here. So 4 times 180 is 720 degrees. So the interior angles of a hexagon are going to add up to be 720. Doesn't matter as long as it's a convex hexagon. Kind of cool, right? And notice that this multiplication that we're doing, this is simply the same thing as this formula, right? 2 times 180. That's 4 sides minus 2 is 2 times 180. We're just performing this calculation to come up with the angle sum. So that's it. We need to know this n minus 2 times 180 formula. This is something we're going to need to make use of, especially if we are not going to memorize all of these particular values, which I'm not going to expect you to do. We can just memorize that formula. All right, let's go ahead and move forward here. So let's calculate the sum of the interior angles of the following polygons. So for a quadrilateral, again, we're using this formula where n is the number of sides. So a quadrilateral has 4 sides. So that's 4 minus 2 times 180. I know we just did this up there, but I want to reiterate using it, which is 2 times 180, which is 360 degrees. So for all quadrilaterals, the interior angles will add up to 360. That's one we're probably going to memorize. We'll work with quadrilaterals enough throughout this unit that we'll probably keep that one memorized. But some of these other ones, we can just go back to the calculation whenever we need it. A decagon, think about it. How many sides does a decagon have? It's like a decade. That's 10 sides. So 10 minus 2 times 180. That's 8 times 180. And fortunately, I have a calculator here to do this. 8 times 180 is 1,440. So the interior angles of a decagon will always add up to 1,440 degrees. Pretty big number there. with a 10-sided shape like that. Last one, even more sides. We have a 15-gon, which obviously has 15 sides. So we can do this quick calculation here. 15 minus 2 times 180. That's 13 times 180, which again, conveniently, I have a calculator to see that that's 2,340. So for our decagon, the angle sum, the addition of all the interior angles is this measurement, 2,340 degrees. Cool. So those are the interior angles, right? The angles on the inside of the polygon. We also have a theorem for the exterior angles, and this one's pretty cool. Real quick though, the exterior angles, right? It's really important to know, are formed by extending the sides out, and then the angle that gets created between that extended side and then the side of the polygon, that's the exterior angle. And so every polygon is going to have the same number of exterior angles as interior angles, which is also the same as the number of sides, right? Another thing that's important to note is that every single exterior angle and interior angle pair, they form a linear pair, right? So they're supplementary. So whatever the interior angle is, the exterior angle will be its supplement. So let's say that this one's like 108 degrees, then this exterior angle would be 72 degrees, so that they add up to be 180. All right, so the polygon exterior angle sum theorem says this: they add up to 360, no matter what. Doesn't matter if it's a triangle or a pentagon or an octagon or a 30gon, they always add to be 360. That's useful. That means we don't have to memorize a bunch of stuff. Always 360, doesn't matter the number of sides. But why? Here I have a bit of an algebraic proof, or at least guide through why this happens. So we're going to let S represent the sum of the exterior angles. Again, we know it's 360, but we're going to try to show that it's 360. So we have S right here, the sum of the exterior angles. And kind of the key to this one right here is this: we have to recognize that all of the angles, both interior and exterior, for any polygon with insides can be represented using this formula. That's because at every vertex, there is an interior angle and an exterior angle, and those things are supplementary. They will add up to 180. So it's 180, 180, 180, 180, 180. All of those will be 180. And there's going to be n of them, n being the number of sides. So for this pentagon, there are 5 supplementary angle pairs here, right? And so however many sides there are, there's going to be that many. So this is all of them. This is all of the interiors and all the exteriors added together. Got to understand that. That's key. And now what we're going to do is we're going to take away the interior angles, which we just saw, right? 180 times n minus 2, that is the interior angles. So this formula is basically saying the exterior angles equals the interior and exterior minus the interior, right? And that kind of makes sense. If we have the interior and exterior and we take away the interiors, what's going to be left over? Just the exterior angles. And so by simplifying this, we will show that it has to be 360, no matter what n is. Let's run through the algebra here. So S equals 180 n. We'll distribute this 180 in here, this negative 180, so it's minus 180 n plus 360, right? 180 times 2. 180 n minus 180 n, those things cancel out, and we end up with S, the sum of the exterior angles, equals 360. It's a constant. There's no more n. It doesn't depend on the number of sides. It is this fixed constant value, 360 degrees. I think that's pretty cool. It's pretty useful at the very least. All right, let's go ahead and answer some questions about the interior and exterior angles of some polygons. So here we have another question. What is the measure of each interior and exterior angle in a regular nonagon. So regular means all angles, all sides congruent. What we care about are the angles. And a nonagon means 9 sides. We could do this in a couple different ways. We could start by finding the exterior angles. We know they're going to all add up to 360, and there's 9 of them. Right, so we could start with that. Exterior angles. So there's a total of 360 degrees spread out among 9 angles. So in that case, we do that division, we get 40 degrees. So each exterior angle as you go around of a regular nonagon, it's going to be 40 degrees. Then let's go ahead and calculate the interior angle. Some of you might be shouting at me right now, like, you already know it, you already know it. I do, but we're going to go through it. So we're dealing with a regular nonagon. So we know that the angles will all add up to, in 9 minus 2 times 180. That's going to be the sum of the interior angles, all 9 of them added together. So then if we divide that by 9, that's going to be a measure of each angle. So let me do this calculation. 9 minus 2 is 7 times 180. Divided by 9 is 140. So that tells me that each interior angle will be 140. Why did I say that I already knew that? Well, if I know the exterior angle, I know the interior angle needs to be supplementary to it. 40, 140, they add together to be 180. So actually, I didn't need to do this calculation. If I find the exterior, I know the interior. Now, vice versa, if I started with the interior, I don't need to do this other calculation. I know what the exterior is going to be. Again, all of this is contingent on the fact that we're dealing with a regular nonagon. Regular has to be regular for these things to work out the way we're doing it, because now we know that all the angles are going to be equal, right? If we didn't know it was regular, they could be sort of anything. You know, we would know what they add up to be, we didn't know what the measure of each one was. All right, you can see this question down here. Please pause and try to answer this question. It says measure each interior, also find the exterior. I'm going to go ahead and start doing this. So I'm going to start with the interior this time, just because. So for a dodecagon, that's 12 sides. So it's going to be 12 minus 2 times 180. All of that divided by 12. That's going to give me the measure of each angle. So I get 150 degrees. So each interior angle is 150. And then remember, the exterior angle is supplementary. So it's going to be 180 minus 150. It's 30, right? The exterior angles are going to be 30 degrees. And again, remember why, right? Why? If we draw out a little sketch, right? This being the interior of our polygon, and we know that this measure is 150, they make a straight line, right? The exterior angle is formed by extending the side, and then the angle here that gets formed between that extended side and then a side of the polygon. And so they always form a linear pair. So it's 30 in this case. So for the next few problems, we're going to be using the polygon angle sum theorems, the interior angle sum theorem, the exterior angle sum theorem to kind of solve these problems. Feel free to pause at any point and kind of work ahead of me. So we have this quadrilateral here. We're going to try to write and solve an equation for C. In this case, we know that there are 4 angles in this, and we know that it's going to add up to 360 degrees because it's a quadrilateral. So that's C plus 3C plus C plus 3C equals 360. Again, that is because, you know, if we haven't memorized or whatever, great. But that's also because if you calculate it, what the angle sum for a quadrilateral is, you get 2 times 180, which is 360, right? This is where I'm getting it. You don't have to have it memorized. You can always go back to that formula, but make sure you put the right sum there. If you don't, if you say 180 because you're just thinking about triangles for whatever reason, you're going to be wrong. Make sure you put the correct sum there. Anyway, let's go ahead and solve that. Combine these like terms. We have 8c equals 360. Divide both sides by 8. We get c is equal to 45 degrees, or just 45. Guess we don't really need to write degrees on this because there's already degree symbols there. C is 45. Okay, let's go ahead and move forward. Now, in this next problem, again, you can pause at any point and work ahead of me. For this next one, we are dealing with a 1, 2, 3, 4, 5. This is a pentagon, but it doesn't actually matter that it's a pentagon because we are dealing with exterior angles. These are all exterior angles, right? So we know no matter how many sides a polygon has, the sum is going to be 360. It's always going to equal 360 for the exterior angles. Interiors will change, exteriors remains the same. So anyway, let's add these all together. That's 7a plus 2a plus 3a plus 6a plus 2a. Adding these all together, we get 20a equals 360. And then we divide both sides by 20. We figure out the value of a in this case is 18, right? Same thing as 36 divided by 2. And then if we wanted to, we could now take this value and solve for certain angles, but we're good with that. Final question here on our paper. We have this problem. Real quick, you know, it's maybe not super clear, but these are marked as congruent to one another. So this one is also 113. Small thing, but just make sure we make note of that. Otherwise, it's not necessarily solvable. All right. We have the interior angles of a pentagon, right? So a pentagon, what do those add up to? That is 540 degrees. Why? Again, formula. 5 minus 2 times 180. N minus 2 times 180. That's 3 times 180, which is, again, 540 degrees. So that's how I know that it's going to equal 540. Now, this is an equation. I need to add all of these angles up and set them equal to this. So I have 113 plus 4x plus 113 plus 2x plus 9 plus 3x plus 8. Almost ran out of space, but we're good. We're going to combine like terms. We have x's here. That's going to be 9x. And then I'm going to quickly add these other ones together. That's 113 plus 113 plus 9 plus 8. Okay, so 243. And then it's just a matter of solving this. So there we go. Get x equals 33. And then again, if we wanted to, if we needed to, if we were asked to, we could take that number, plug it in, figure out any of these particular angle measurements. There we go. All right, make sure you try the homework, and I'll see you guys in class. Have a good weekend.